Hi there. Today we're going to discuss factor linear expressions. Objectives and standards. Today we're going to learn how to find the GCF of monomials, and we're going to factor linear expressions. Step 1. How to find the GCF of monomials. Find the prime factorization of each monomial. Step 2. Circle the common factors. Step 3. The GCF is the product of the common factors. Find the GCF of the pair of monomials, 4x and 12x. So 4x can be written as 2 times 2 times x, and 12x is written as 2 times 2 times 3 times x. Now we're going to circle our common factors, 2, 2, and x. So our greatest common factor is going to be the product of those factors. So that equals 4x. Example 2. Find the GCF of the pair of monomials, 18a and 20ab. 18a is 2 times 3 times 3 times a. 20ab is 2 times 2 times 5 times a times b. Now we're going to circle our common factors. We have 2 in common, a in common, and nothing else. So our GCF is going to be a product of 2 times a, or 2a. Example 3. Find the GCF of the pair of monomials, 12CD and 36CD. 12CD is 2 times 2 times 3 times C times D. 36CD is 2 times 2 times 3 times 3 times C times D. Now let's circle our common factors, 2, 2, 3, C, and D. So our GCF is 2 times 2 times 3 times C times D, and that equals 12CD. How to factor linear expressions. Step 1. Find the GCF of the monomials. Step 2. Write each term as a product of the GCF and the remaining factors. You're going to have it in the form A times B plus A times C, where A is going to equal your greatest common factor. Step 3 is to rewrite using the distributive property in the form A times quantity B plus C. Example 4, factor 3x plus 9. So first we're going to find our greatest common factor, GCFs. So 3x is 3 times x, and 9 is 3 times 3. What we have in common is just 3, so our GCF is 3. So we want to write 3x plus 9 as a product of the GCF and whatever is remaining. So here for 3x, if we take out the 3, we have a remainder of x. And then here in 9, if we took out this 3, the remaining is 3. Now this is in the form a plus b, a times b plus a times c. Now we want it in the form a times quantity b plus c. So I'm going to take out my greatest common factor and put it outside. And what I'm left with is x plus 3. So this is the factored form of 3x plus 9. Here's another example. We have 12x, and the prime factorization is 2 times 2 times 3 times x. Prime factorization of 48 is 2 times 2 times 2 times 2 times 3. Now let's circle what they have in common. They have a 2, and a 3. So our GCF is going to be 12. So we have 12x plus 48. Okay? So we want to pull out the 12. Okay, and in 12x, whatever's remaining, that is x. And what is remaining in 48? 2 times 2, which is 4. So now we want to rewrite it using the distributive property. So the 12 is in common, it comes on the outside. And what are we left with? X plus 4. Here's another example. Factor 12x plus 7y. So we have 12x, that equals 2 times 2 times 3 times x. 7y is 7 times y. And if you'll notice, they don't have any factors in common. So if they don't have any factors in common, we would just write cannot be factored. And that's because the greatest common factor is just 1. Here's another example, 3x plus 11. Okay, so 3x is 3 times x, and 11 is just 11. So here we don't have any common factors, so we're just going to write cannot be factored. Okay, here's some applications for our factoring linear expressions. The drawing of the garden at the right has a total area of 15x plus 18 square feet. Find the possible dimensions of the garden. And remember, this is a rectangle, so we have a length times a width. Okay, so what we're going to do is we're going to take this expression and factor it out so that we can find the possible dimensions. So 15x is 2 times, I'm sorry, not 2 times 5. It's 3 times 5 times x, and 18 is 2 times 3 times 3. The ones that we have in common is 3. Anything else? No. So our greatest common factor is 3. So 15x plus 18 is going to be written as a product of 3 and whatever remaining factors we have. So out of 15x, if we took out the 3, we're left with 5 times x, or 5x. And then in 18, if we took out the 3, we're left with 2 times 3, or 6. So now what we want to do is rewrite it in the form A times quantity B plus C. So our 3's are in common, we're going to pull that outside, and we're left with 5x plus 6. Okay, so the possible dimensions are 3 units, or 3 feet. I'm sorry, the units they did give us is 3 feet by 5x plus 6 feet. Okay, so there are 2 dimensions, a length and a width, so 3 feet by 5x plus 6 feet. Lily's favorite picture has an area of 3x plus 12 square inches. Find possible dimensions of the picture. Again, so this is a picture frame, and we have a length and we have a width. So what we're going to do is we're going to factor 3x plus 12 to find that out. So 3x is 3 times x, and 12 is 2 times 2 times 3. So the common factor here is 3. So my GCF equals 3. So let's rewrite 3x as the greatest common factor 3 and whatever's left over. So if I took out the 3, I'd be left with x. And then here, same thing, the 12, if I took out the 3, I'd be left with 2 times 2, and that equals 4. So now I want to rewrite this using the distributive property. So our common factor was 3. Let's pull that outside. And we're left with x plus 4. So the possible dimensions are 3 inches by x plus 4 inches. Okay, so today we use properties of mathematics to factor linear expressions. Hope that video was helpful. Thank you. Bye.